Hello students, we know that for a quadratic equation ax square plus bx plus c equals to 0, roots of the quadratic equations are x equals to negative b plus minus square root of b square minus 4ac over 2a. Here, b square minus 4ac is called discriminant and usually denoted by delta, and value of the delta or value of the discriminant decide what would be the nature of the root. For example, if delta is strictly more than 0, then we have real and unequal roots. If delta equals to 0, then we have real and equal roots. If delta is less than 0, then we have no real roots or we have pair of complex roots. Let us see this through some examples so that we are able to understand what is the exact role of discriminant. So in this question, we have a pair of standard quadratic equation, and we have to find what would be the nature of the root for these equations. So compare this equation, uh, compare this equation with the standard quadratic equation we get. So if we compare this equation with ax square plus b times of x plus c equals to 0, we get a equals to 1, b equals to -1 coefficient of x, and c equals to -20. Let us find discriminant. So here discriminant is simply b square minus 4ac. Let us plug the value of a, b and c. So b is -1 minus 4, a is 1, c is -20. Let us multiply. So we get 1 minus -20 into -4 is 80. After adding, we get 81. So obviously delta is strictly more than 0. So we get two real and distinct roots, and distinct roots for the given quadratic equation. Let us see this quadratic equation. If we again compare with the standard quadratic equation, then we get a equal to 9, b equal to -24, and c equal to 16. Let us find discriminant for the given quadratic equation. Our discriminant is b square minus 4ac. Let us plug the value of a, b and c. So -24 whole square minus 4 times of 9 times of 16. Now 24 square is 576 minus 4 nines are 36 into 19. Oh, C is 16, not 19. So it becomes 16. So once we multiply 36 into 16, again we get 576. So we end up getting 0. Our discriminant is 0. So we get real and equal roots. Okay, let us see one more question. Again, we have to find nature of the root, and our quadratic equation is 2x square minus 2x plus 9 equal to 0. So compare this quadratic equation with ax square. Here we have to compare this with ax square plus b times of x plus c equal to 0. We get, after comparing, we get a equals to 2, b equals to -2, and c equals to 9. Now let us find discriminant, which is b square minus 4ac. So our discriminant is negative 2 square minus 4 times of 2 times of 9. So this is 4 minus 72. This is minus 68. Obviously, we can see that our discriminant is less than 0. So we get pair of complex roots, pair of complex roots, or we can say, no real root for this quadratic equation. For given quadratic equation, let us see one more question. Here we have to find k so that this quadratic equation has no real root, and we know if discriminant is less than 0, then we do not get any real root. So again, compare this quadratic equation with the standard quadratic equation. We get a equals to k plus 9, b equals to k plus 1, and c equals to 1. Let us find discriminant now. Our discriminant is simply b square minus 4ac. So k plus 1 whole square minus 4 times of k plus 9. C is simply 1. Let us solve this. So we get k square plus 1 plus 2k minus 4k minus 36. Let us simplify this. So we get k square, 2k minus 4k is negative 2k minus 35. Since given quadratic equation has no real root, so delta is less than 0 since we have no real root. Since given equation or given quadratic equation has no real root. So we can rewrite this as k square minus 2k minus 35 is less than 0. Let us factorize this. So after factorizing, we get k square minus 7k plus 5k minus 35 is less than 0. Here we have to find pair of numbers such that their sum is negative 2 and product is minus 35. Now we can write k minus 7 into k plus 5 is less than 0. Let us simplify this inequality. So basically we have k minus 7 into k plus 5 is less than 0. In order to simplify this inequality, draw a number line. If we put k minus 7 equal to 0, then we get k equal to 7. There is a hole at k equals to 7 because at k equal to 7 we get 0, and this is strictly less than 0. Now similarly, if we put k plus 5 equal to 0, we end up getting negative 5. So there is another hole at negative 5. Now if we take any number like put 0 in this equation, so we get negative 7 into 5, which is less than 0. So mark a negative sign. Again, if we choose a number more than 7, like 8, put 8 here. So we get positive number, their product is also positive. Similarly, if we mark a negative number less than negative 5, then we get a negative number, their product is positive number. So finally, we find k belongs to negative 5 to 7. Or we can say k is more than negative 5 and less than 7. So if k lies in this interval, then given quadratic equation has no real root. Let us see one more question. Here we have to find the value of k so that this equation has equal roots, and we know we have equal roots if discriminant is equal to 0. So compare this equation with the standard quadratic equation. We get a equals to 2, b equals to negative, k minus 2, and c equals to 1. Now d is equals to 0 or delta is equals to 0 since roots are equal. Since roots are equal. So let us plug the value of everything. We have b square minus 4ac equals to 0. So square of b square is simply k minus 2 whole square minus 4, a is 2 and c is 1 equals to 0. So k minus 2 whole square equals to 8. Taking square root on both sides, we get k minus 2 equals to plus minus square root of 8, or we can say plus minus 2 root 2. So k minus 2 equals to 2 root 2. So k equals to 2 plus minus 2 root 2. So for these value of k, given quadratic equation has equal root. Hopefully all of you find it helpful. If there is any doubt or concern, let me know in the comment section. Thank you.